So what if AI could do more than just talk? I mean, we're all used to chatbots, right? But what if AI could build a perfect virtual copy of our physical world? A literal blueprint for reality itself? Well, that's the wild idea behind a technology called a digital twin, and it's all powered by a new kind of AI called a world model.
And look, this isn't some far-off sci-fi concept. This is a booming industry right now. By 2027, the market for digital twins is projected to hit a staggering $73.5 billion. Let that sink in for a second. That's more than a tenfold jump from just 2021. The growth here is absolutely exponential.
So that kind of explosive growth makes you ask, right? What is the core technology making this all happen? And why is everyone saying it's the next great leap forward for AI? Let's get into it. Okay, to really get what makes digital twins tick, we have to look under the hood at the engine that powers them. And it's a type of AI that goes way beyond the language models we all know and use. Welcome to the world of world models.
So what exactly is a world model? Well, here's a really simple way to think about it. If a large language model learns grammar to predict the next word in a sentence, a world model learns the laws of physics to predict what happens next in the real world. You see, it's not about language. It's about understanding cause and effect, and that is a total game changer for AI.
And this distinction is absolutely crucial. LLMs are wizards with words, right? Perfect for things like chatbots or summarizing articles. But world models? They get reality. They understand why things happen, the causal relationships, which makes them absolutely essential for stuff like training a robot or running incredibly complex simulations, where you have to know how the real world actually works.
So, how do you even build one of these things? Well, there are basically three main ways people are going about it. First, you've got learned internal models, where an AI kind of dreams up different scenarios to figure out its next move. Then, there are external simulators. You can think of these as super sophisticated video games, basically pre-built virtual worlds for AI to train in. And finally, the Holy Grail, the World Foundation model. That's the dream of a general-purpose AI that could theoretically simulate just about anything. Now, a technology this revolutionary, you know it's going to kick off a global race. And right now, the two most fascinating players in the game are the US tech giant NVIDIA and a whole bunch of ambitious companies in China. And get this, they each have a very, very different strategy for building the future. NVIDIA is making a massive all-in bet. Their core belief is that the only path to true artificial general intelligence, AGI, is through incredibly realistic, high-fidelity simulators. In other words, if you want to create an AI that truly gets our world, you first have to build a perfect digital copy of it to train that AI in. Their whole strategy is built around something called the Omniverse. It's a complete end-to-end platform. They make the chips, the networking gear, the software, the whole shebang. And this creates this powerful simulation flywheel. The more companies use the Omniverse, the more data gets generated, which in turn drives demand for more of NVIDIA's hardware. It's a brilliant self-reinforcing loop. And it's already working. Look at Foxconn. They used it to cut their factory setup time in half. Half! Okay. So while NVIDIA is chasing that hyper-realistic perfection, China is playing a completely different game. Their whole approach isn't about creating flawless simulations. It's about creating models that are good enough for most things, but at a tiny fraction of the cost. This is a strategy built on making the tech accessible and just dominating the market. So how are they pulling this off? By optimizing for resources, not just raw performance. Take a model called DeepSeek R1, for instance. It launched with inference costs, that's the cost to actually run the AI, that were 90% lower than the top models in the West. By making their models open weight and super cheap to run, they're aiming to grab that huge market for all the routine, everyday AI tasks. And at the same time, you've got giants like Tencent pushing the envelope with brand new physics-aware models.
All right, so we've got this incredible new tech, we've got a global race to build it, but what can you actually do with it? Let's dive into how digital twins are already replicating and improving our world in some pretty mind-blowing ways.
First up, let's start big. Imagine creating a complete, living, breathing digital replica of an entire city. That's the idea behind a cognitive city. Urban planners can simulate traffic flows, they can monitor infrastructure in real time, and even model the impact of new policies before they ever happen in the real world. And the results are, well, they're incredible. The Virtual Singapore project, which is exactly what it sounds like, a full 3D digital twin of the entire city-state, led to a 20% improvement in urban efficiency. That's a huge deal, impacting everything from your daily commute to energy use for millions of people. Now here's a cool fact. This entire technology actually has its roots in the aerospace industry, and they are still a huge player today. Companies are using digital twins for literally everything, from designing the next generation of jets to predicting when an engine that's flying high above our heads right now is going to need maintenance.
And the growth in this one sector is just phenomenal. The aerospace digital twin market is projected to shoot past $50 billion by 2034. That shows you this is a fundamental shift away from building expensive, slow, physical prototypes to doing everything with fast, efficient virtual testing.
But one of the most powerful applications, and frankly one of the most important, is in disaster management. By creating digital twins of things like coastlines and river systems, and then feeding them real-time weather data, authorities can predict the path and impact of floods with incredible accuracy. This allows for way better preparation and response.
And this isn't just theory, it's technology that directly saves lives and property. In the Netherlands, their Digital Delta program uses water management digital twins to achieve a 40% reduction in flood damage risk. That is a life-changing number, all thanks to having a better blueprint of reality.
And the applications are just popping up everywhere. We're seeing fully automated dark factories being run entirely by digital twins. The gigantic 42-kilometer-long port of Rotterdam is being optimized with one. In robotics, NVIDIA's virtual worlds are safely training the next generation of machines. It's even making our skies safer, cutting drone near misses by 90%. And in finance, it's creating a super secure way to track tokenized assets like real estate and art on the blockchain. The list goes on and on.
So when you can simulate factories and cities and even weather patterns, what's the ultimate application? Where does this all lead? For many, the answer is national security and defense, where a perfect simulation, the kind NVIDIA is chasing, can mean a decisive advantage.
The integration of digital twins into military operations is nothing short of a revolution. It's being used for everything you can imagine, from training soldiers in incredibly complex combat scenarios to planning operations and even performing real-time maintenance on the most advanced military hardware out there.
And as you'd expect, every major global power is developing its own playbook. The US is leading the way in investment. The F-35 fighter jet, for example, has 300,000 sensors on it, constantly feeding data back to its digital twin. Meanwhile, you've got nations like France and India that are really focused on building their own domestic capabilities. And China is dead set on being completely independent from any foreign tech in this area.
And all of this brings us to a final, really profound question. We are creating digital blueprints of reality that are becoming more accurate, more predictive, and maybe even easier to understand than the messy real world itself. So, as we head into this future, we have to ask ourselves, when the simulation becomes just as real as reality, which one will we choose to trust?